A very good day to madam. My name is Kek Kai Ting with matric number 271613. So now I'm going to start my presentations about our assignment 4. So let us see the question 1 first. Okay, for the questions 1, email spam filtering model often use a bag of words representations for emails. So our purpose to do this question 1 is to determine that whether this email is a spam or not. Okay, so for the question A, create a bag of words table to represent the content of the 5 emails where the values of spam, which is the target features for the emails, are true, 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 false, false, respectively. So we have totally have 5 email at here. So I have created that for the ID 1 is represent the money, money, money. And for the ID 2 is represent the free money for free education fund. And for ID 3 is represent the education for fun. And for the ID 4 is represent the machine learning for fun, fun, fun. And the ID 5 is represent the free machine learning. Okay, so now let us see the ID 1. So for ID 1, they have money, 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 3 words in here. So we have write down the 3 in below the money. And for the free for education fast machine learning is not included in the email 1. So we write here as 0, 0, 0, 0, 0, and 0. So we apply the same technique to the rest of the ID. So it's just for the back of our table is like this. And for the spam status, the above questions have listed is true, 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 false, false. So we write here is true, 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 false, false. Okay, so for the question B, he asked that what target level would a nearest neighbor model using returns distance return for the following emails machine learning for free. So we do the same table as money free for education fund machine learning, and we want to determine that whether this email is a spam or not. Okay, so for the machine learning for free, so we write down the 1 in below the free, write 1 for the 4, and write 1 for the machine learning, and for the rest of the money education and fund we write as 0 because it is not appear in this email machine learning for free. Alright, so now we need to apply the formula of illusions distance. So this is the formula of illusion distance. So we calculate for ED1 to ED5. So ED1 is the calculations for the ID1. So we apply the formula in ED1 to ED5, then we can get the answer. So we jump to the table that I have done. So this is the ED, the amount of ED that I have get. So for the ID1, I get the ED is 3.606, and for ID2, the ED is 2.449, and for ID3, the ED is 2.236, and for ID4, the ED is 3.162, and for the ID5 is 1.000. So after this, we need, because we want to find the nearest neighbor, so the amount that nearest to the 1 is represent the nearest neighbor. So we need to rearrange this table from the smaller to the biggest. So after I have rearranged, the ID represent is for 5, 3, 2, 4, 1. So we can see that the ID5 have the nearest ED, which is 1. So for the ID5, the spam status for ID5 is a false. So for the conclusion, I can say that based on the calculations and the table above, we can note that the nearest neighbor is ID5 and its spam status is false. Therefore, for this query, it was predict spam equal to false. Okay, so that's all for the question B. Now let us see the question C. So for the question C, he asked that what target level would a KNN model with K equal to 3 and using the Eurodance distance return for the sense query as in B. So we just use the same table like this. So because now is K equal to 3, so we find the 3 nearest neighbor. So based on the table, we can see that the 3 nearest table is ID5, ID3, and ID2. So my conclusion is, when K equal to 3, we need to select 3 nearest neighbor for this query, which are ID5, ID3, and ID2. So from the table above, we can see that the spam status for ID5, ID3, and ID2 are false, true, and true respectively. So we can know that the majority of the spam status is true. So therefore, we can conclude that this model will predict spam equal to true. Okay, so that's all for question C. So now let us look for the question D. So for the question D, he asked that what target level would a KNN model with K equal to 3? And now we need to use the Manhattan distance return for the same query as in B. So now we need to apply the Manhattan distance formula in these questions. So same as just now we do for MD1 to MD5, and the table and the answer that we get is like this. So for the ID1, the MD that I get is 7. For ID2, the MD that I get is 6. For ID3, the MD that I get is 5. And for ID4, the MD that I get is 4. And for ID5, the MD that I get is 1. So we need to rearrange the table like just now from the smaller to the biggest. So after I rearrange the table, I know that the ID543 is the smallest MD when K equal to 3. So the conclusion that I have written is based on the calculations and the table above, when K equal to 3, we need to select the 3 nearest neighbor for this query, which are ID5, ID4, and ID3. And for the table above, we can see that the spam status for ID5, ID4, and ID3 are false, false, and true respectively. So we can see that the majority of the spam status is false. So we can conclude that this model will predict the spam equal to false. Okay, so that's all for question D. So now let us look at the question E. So the question is said that there are a lot of zero entries in a spam box of word data set. This is indicative of sparse data and is typical for the test analytics. So code size similarity is often a good choice when dealing with the space non-binary data. Excuse me. So what target level would a 3NN model using cosine similarity return for the query as in B? So we need to detail on how I detail the answers are obtained from the questions 1B to 1E. So for these questions, we need to apply the formula of cosine similarity. So this is the formula of cosine similarity, and then I have done for the CS1 to CS5. So let us see the table that I get. So for ID1, the cosine similarity that I get is 0. And for ID2, the cosine similarity that I get is 0.5303. And for ID3 is 0.2887. For ID4 is 0.4330. And for ID5 is 0.8660. So for these questions, we also need to rearrange the table from but this time is the biggest to smaller. It is because the higher of the cosine similarity, the higher the similarity. So after I rearrange the table, I know that the ID5 have the biggest CS, which is 0.8660, and so when K equal to 3, we need to select the 3 highest similarity for this query, which are ID5, ID2, and ID4. So from the table above, we can see that the span status for ID5, ID2, and ID4 are false, true, and false respectively. So we can see that the majority spam status is false. Therefore, we can conclude that this model will predict the spam equal to false. Okay, so that's all for the question 1. So now let us look at the question 2. So for the question 2, we need to prepare and discuss one orange word from and demonstrate the use of the nearest neighbor as a predictive model. So now I'm going to show you how I do this work in the orange. So this is my orange. First of all, we need to download the dataset from any open website. So the dataset that I've downloaded is from the orange. So the dataset that I use is the breast cancer weaknesses. So the questions want us to have at least 300 records and 5 descriptive features excluding the class and target features, and 2 classes or group in the target features. So we link to the table. So first of all, we link to the table and we can see all the data in here. Okay. So after that, we need to find out whether the data set that we found have how to say have meet the requirement or not. So we link it to the data info, and we can see that the data total have 683 rows, and the numerical instance is 2, and it has a target which is the categorical outcome with 2 values. So we can know that the data set that we found is meet the requirement of the questions given. Okay, so after that, we need to divide the data set into two portions, which is 80% for the training and 20% for the testing. So we need to link with a data sample, so we can adjust in here with how many percent that we need. So we need to adjust it to the 80 because the question requirement is the 80% for the training and 20% for the test. So after we have set the fixed populations for data, we need to pick the sample data, and we can see that the train data is 547 and the rest are the test data. Okay, so after we set the data sampler, we need to link it to the KNN. So in here for the KNN, we can set the number of neighbors that we need to use. For example, for the first, I set it to the 5. So after that, I link it to the test and score. So I can see the evaluations result. We have total 2 because we can link the data sampler to the test and score and choose the data sampler to a data and the remaining data for test data. So after we set these parallel links, we can go to the test and score and click the data that we want to see the evaluation result. For example, if we want to see the trend data, we can click on the test of trend data, and it will appear the evaluation result for the KNN equal to 5. Why is 5? Is because we set the KNN in here is the number of number is 5. So here the data, sorry, so here the test and score for the model is KN equal to 5. So here is for the trend data. If you want to see a test data, we just need to click on this test data, and the evaluation result is for the test data now. Okay, so after that, if we want to see the summarized evaluation result, we can link it to the confusion matrix. So in the confusion matrix, we can see 3 of the result in here. For example, first is a number of instances, and the second is the proportions of predicted, and the third is the proportions of actual. So now we can see that this is for the test data. If we want to see the trend data one, we need to adjust at the test and score. We click on the trend data. So the summarized evaluation result will be changed to the trend data one. So we can adjust. Let's see, we need to see the what of the evaluation result. Okay. After that, for the question C, it needs us to perform various experiments using 3 different K values and sports simulated metric. So we need to change the KN in here. For example, just now it's 5, now we change to 11. Wait a moment, we change to 11. And we can change the metric in here. There are totally 4 metrics here. One is Uranus, Manhattan's, Canvases, and Manhattan's. So if we want to test the 4, we just need to click it one by one. For example, now we click here and we see the test and score, they have changed already. And for the confusion metric, it's also changed. So we just need to click here and change the metric. We can see a different result. So this is just a workflow for this orange. So for the results, so I have concluded the result in the table. Okay. Okay, so when I have do for 3, which is the 5, 7, and 9. So if you want to see the further result, you can go to my report and see the result that I have done. I've arranged it in a table. Okay, so that's all for my presentations. Thank you.